Here's Alice and Bob again. Bob has a colorfish these days, and his colorfish is in a bowl that's specific to colorfish, and he wants Alice to take care of his fish while he's on vacation. And Alice says, sure, you give me a bowl with a fish inside of it, and when you get back, I'll give you a bowl with the fish inside of it back. So Bob hands over his fish and goes on vacation. Meanwhile, Alice says, let's move the fish to this other bowl. I've got this more general bowl that can deal with any kind of fish, including colorfish, so that'll be an upgrade for Bob. And Bob gets back and he notices the bowl is different. And he's not sure whether to be happy about this. This seems a little odd, but it could be even worse because it's a generic fish bowl. He could have lost the colorfish inside. Maybe Alice gives him back just a regular old gray fish. Now, Alice didn't break any contracts here because Alice said, you give me a bowl with a fish inside of it and I'll give you back a bowl with a fish inside of it. So that's what we get from functional updates here. Bob had to hand over his bowl and get the bowl back. So let's say Bob takes a different strategy. Bob is in an imperative world instead. And so Bob is going to leave his fishbowl behind. The fishbowl has to stay right there. And he's going to tell Alice, can you take care of the fish in my fishbowl while I'm on vacation? So, sure, Alice says, sure, I can do that. You point me to a bowl with the fish inside of it, and I'll take care of it. And, you'll just get back true because, any sort of fish food I'll dump in actually in that bowl and take care of the fish that way. So Bob goes on vacation, but while he's away, then Alice says, I like this gray fish better, so I'm going to drop it in the bowl instead. Now, Alice's action seems to be justified to her because she got a bowl that takes any fish. But when she put a gray fish inside of it and Bob gets back and looks, his fish is not a colorfish anymore. Furthermore, this gray fish is going to die because his bowl only works for colorfish. Nothing in the type here gave Bob any warning that his fish was going to kill off. It was an unfortunate side effect of a colorfish bowl being a subtype of bowls, fish bowls. So something has gone wrong in the type system here. In a world where fish bowls can be imperatively updated, a colorfish bowl should not be treated as a subtype of a fish bowl. Let's take these intuitions back to our code and see whether things are working right or not. So here we have our function that takes a record that just has an x field, and it does an update on that record to change the x field's value to 5. If we pass it a record that has both an x and a y field, there's no problem, right? The function's expecting an x. We're giving it something with more fields, whether it's functional update, and we get back a record with x changed, or an imperative update, where it actually changes this record, there is no problem here. So far, where we've defined our subtype relation to have extra fields in subtypes compared to supertypes, that seems to work out for both functional and imperative update. The problem with this rule is actually in this less than or equal sign right here. So let's make our example more complicated. Let's go back to the one where the function f takes a record that has a p field, and then the value of that p field is another record that just has an x field. Locally, this looks fine. Whether we do a functional or imperative update, we take that record and we change the p field to a different record that has an x field consistent with the type. And if this is functional update, then the type on f will say the result type is the same record type here. What if we provided a record where p starts out with x and y fields? Well, then according to that functional update type, what we get back will have a p field, but it will not have a y field. So the type system will reject this, which is right, because it would not work at runtime. There will be no y field in the result that we pass back from this function. All right, so what's going on is that we're allowed to pass things in, right? Having the same number of fields but a subtype in the field works fine for functional update. And we correctly reject this program in functional update. But if the imperative setting, where we put some record r here, call f on r, and then after that look at r, then it doesn't matter what the result type of f is. R, as a record, is supposed to have the type p, and then if the record inside that has an x and y. But if f can imperatively change p to have a record with just x field, then this line will go wrong, and our type system so far is not catching this. Right? And the problem is that we are allowing this subtype relation here, but this subtype relation can get broken by imperative updating. So the rule is that this is wrong for imperative update, and the way you fix it for imperative update is to change it back to equal sign. In other words, with imperative update, field types are invariant with respect to record types, not covariant and also not contravariant.